by RT combinatorial part, which is multiply is very simple. Your formula is given nx1 ln phi1 by x1 plus nx2 ln phi2 by x2 plus nz by 2 q1 x1 ln theta 1 by phi1 plus q2 x2 ln theta 2 by phi. Again I am talking about the binary system. With the multi-component system, maybe you can do some research on inequality and unifact. That's a research topic. So here, from here, you can think about the, if you want to talk about the solution from dynamics system, activity coefficient models, there are a lot of things available. And the big guy who does research, if you can start research papers, if you want to take the research project, maybe a MTech project or your PhD project, the papers with whose paper we have to follow, the guy's name is Prasnis. So look at the Prasnis paper. Prasnis has famous papers on this. Prasnis has a book, Theory of Liquids. So look at Prasnis paper. If you want to talk about the vapor, you want to, okay, I want to master vapor equilibrium. I want to talk about activity coefficient models. Okay, we start with the Prasnis. Prasnis is the right guy. Let's start the problems. He has done development of activity coefficient models and start from there. And still the uniquely unifact is the thing, the topic for the research. People are developing on that, and lot of models are actually available. And in fact, these kind of models are also supplemented by statistical thermodynamics, which is out of the course. Maybe some advanced course we look at the statistical thermodynamics. That feedback should be given to the models, can be and which can give the better solution thermodynamics or better activity coefficient models. On that, we can start going for the ln gamma 1c. I will say combinatorial part of the activity coefficient of the first component. ln gamma 1c is the combinatorial part of the activity coefficient, which is nothing but 1 by RT dou GE dou NI dou N1 EP N2, which is the combinatorial, I put C, combinatorial part. Okay, if we talk about the combinatorial part, so I am saying these are the equations, so I can directly write dou N1 of nx1 ln phi1 by x1 plus nx2 ln phi2 by x2 plus dou N1 nz by 2 q1 x1 ln theta 1 by phi1 q2 x2 ln theta 2 by phi2. This I am saying, entire thing I am saying term number 1, and this I am saying term number 2. So such a big expression I cannot deal all together. I will deal first term, and the second one is second term. And this I am saying equation number A. This I am saying equation number A. First we'll start with term 1 of combinatorial activity coefficient of uniquely model. So we'll talk about first combinatorial activity coefficient of uniquely model. So we have, before getting into the first term, so we can write here derivation for term 1. Derivation for term 1. Okay? We can say first is derivation of for term 1. Okay. So we have, we'll just take first this term, nx1 ln phi1 by x1 plus nx2 ln phi2 by x2. Before getting into the derivative, just see whether you can do anything with this guy. We can write this as x1 ln phi1 by x1 plus ln phi2 by x2 minus x1 ln phi2 by x2. That x1 plus x2 goes to 1. Always useful. Use it based on convenience. That's useful for, you can see that all activity coefficient models, it is pretty much useful. And you can see that you are getting in, what is the simplification? If you do that, you have the two terms, x1 and then ln phi 2 by x2. What is the fill in the blanks? What is that? x1 ln phi 1 x2 by phi 2 x1. Phi 1 x2 by phi 2 x1. Equation number 1a. Equation number 1a. So what is phi 1 x2? Phi 1 x2 is, from your expression, what is phi 1? Is the volume fraction. So it is nothing but x1 r1 x2 by summation xi xj qj. So it is x1 r1 x2 divided by x1 r1 plus x2 r2. Am I correct? Yes. Phi 2 x1, which is x2 r2 x1 by x1 r1 plus x2 r2. Am I correct? So phi 1 x2 by phi 2 x1 will be how much? Simplified expression. Can you tell us? Phi 1 x2 by phi 2 x1, how much it is? r1 by r2. So see, you have to simplify this way. Similarly, phi 2 by x2 will be how much? It says very simple, r2 by x1 r1 plus x2 r2. Very basic definition. So from equation 1a, we get n x1 ln phi 1 by x1 plus x2 ln phi 2 by x2 equals to n x1 ln r1 by r2 plus ln r2 by x1 r1 plus x2 r2. Equation 1b. Up to equation 1 is there? Yes. I am telling you once and pretty lucky, this derivation is not there in any of the book, including Google's. You can search Google's. I don't think any other IITs or even ISC they are including this derivation. This is only IIT. Only place maybe in India. Okay. Equation 1b is given. Term I. Recall your term I. What was that? Dou n1 of combinatorial part. nx1 ln phi 1 by x1 plus nx2 ln phi 2 by x2 plus nz by 2 q1 x1 ln theta 1 by phi 1 plus q2 x2 ln theta 2 by phi 2. First term I am writing again from equation number A. First term I am writing from equation number A equals to this. If you take the n out, dou n1 of n is 1, and it will be nothing but first term will be the same, which is x1 ln phi 1 by x1 plus x2 ln phi 2 by x2 plus n, and okay. First time only this much was there. Yes. If I do everything, you can complete. I don't have everything, so I don't want to do that second term here. I just want to first term one at a time. And then n dou n1 of x1 ln phi 1 by x1 plus x2 ln phi 2 by x2. So far everything is okay. It's better to have term 1 and term 2. Otherwise really you get confused. This is okay. We cannot do anything. Now for this, if you want to take derivative, this calculation should be very handy. Because you can, if you do this calculation, you can see number of unknowns is minimized. That's why I have done it. See the kind of derivation, see the kind of mathematical perspective. If you don't know much algebra, if you don't have the intuition, here the engineer's intuition is very much important. If I want to work on this, we have so many unknowns. Here also you have unknown, x1, x2. Here also you have unknown. you get completely confused. But if you do this term simplification, you can see only unknowns are here. It is very easy to take derivative. This is the mathematical perspective. You can take derivative of here. I cannot do. There are so many unknowns. Every term has unknown. It has x1. It has x1. It has x everywhere. But here, only here and here. Very simple. All are constants. R1 is constant and R2 and R2 is constant. Okay. So we just keep this one same. x1 ln phi 1 by x1 plus x2 ln phi 2 by x2 plus n rho n1 of x1 ln R1 by R2 plus ln R2 by x1 R1 plus x2 R2. Correct? Yes? Next step. x1 ln phi 1 by x1 plus x2 ln phi 2 by x2. This you can always write these steps. What did you get? N, first term, quick, this constant, R1 nothing is there. x2 by n, x2 by n, ln R1 by R2. Then, this has got unknown, so it will be 1 by R2 by x1 R1 plus x2 R2 of ddx of, that is also very simple, x2 by n R1 minus x2n by n R2. So I can actually visualize what I am getting because I have done by hand. So still I remember what the juncture is actually required. So it is 1 by x1 R1, x2 R2 and say R1 minus R2 into x2 by n. I have removed R2y. Am I done wrong? I want to say yes from you. If you say you are wrong, I will be happy. If you say I am right, I won't be happy. Am I done wrong? Something I have missed out here, right? Am I done wrong? See, if you take derivative, it is what? It is 1 by R2 x1 R1 plus x2 R2 and then ddx of that. So what I have done here? So you can see ln of a by b is ln a minus ln b, and this is constant. So if you take a separate term, this will go to 0 and you have only minus term. That's why I put minus here. So everywhere you have to be very careful how you can simplify, because if you cannot simplify, if simplification is possible, you cannot get simplified activity coefficient model. Okay, next. So next proceed, how to proceed next? You will get x1 ln phi 1 by x1 plus x2 ln phi 2 by x2 plus this n and n will get cancelled from here and you will get what? x2 ln R1 by R2. Next term minus n and again it will get cancelled. So minus x2 into R1 minus R2 divided by x1 R1 plus x2 R2. You can write this as 1 minus x2 ln phi 1 by x1 plus x2 ln phi 2 by x2 plus x2 ln R1 by R2 minus simplification is required. You can see some simplification can be done in terms of phi and x. What simplification you can do? What the simplification you can do? This x1 R1 x2 R2 is there. That means you know that if you have x1 R1 here, you get phi 1. If you have x2 R2, you have phi 2. What's the simplification here? You reduce the number of unknowns. You will see no unknowns should be there. This should be a constant term. What is a constant term? Not constant, some symbol. Of course, phi is not constant. Phi is having that symbol, but you can actually have the terms of symbol. It's very compact. What is that compact form? Anyone got it? Pardon? Phi 2? Not correct. Please do the carefully, don't guess it. You do the steps. Do the steps, you get it. You do the steps. You do the steps. Have you done the steps? It's still starting.
Phi 2 plus
Phi 2 plus. I am saying, okay, I'll give the guess in the bracketed term. What is the bracketed term? R1? R1 by R2 minus 1. Yes, madam, correct. R1 by R2 minus 1. Got it? R1 by R2 minus 1. Yes. So, next step. Ln phi 1 by x1. Okay, so that's why I put 1 minus x2. So this x2 and this x2 can combine now. Okay, so what did you get? You can have all x2 combined. We have ln phi 2 x2 minus ln phi 1 by x1, and then ln r1 by r2. Okay, 3 terms I got, then that's all. Minus phi 2 r1 by r2 minus 1, correct? Yes. Ln phi 1 by x1 plus x2 ln. How to simplify? Ln a minus ln b minus ln c. Ln a plus b is ln ab. It will be ln ac by d. Okay, what is the term? What did you get? What did you get? Pardon? ln 1, that is 0. That's correct. Okay, and next is minus phi 2 r1 by r2 minus 1. So combinatorial part, first term is evaluated very simple. It looks pretty complicated, but you see that the first term is having only 2 terms. Ln phi 1 x1 minus phi 2 r1 by r2 minus 1. You saw the derivation, the steps, the philosophical perspective. It is not simple mathematical manipulation. Your intuition, how you want to simplify, you have the relationships. So this is the way active equation models have been done. So that's your term 1. That's your term 1. I am saying equation number A1. I am saying equation number A1. Let's proceed for term 2. Let's proceed for term 2. Remember that when I was doing term 2, instead of taking derivative, I was trying to do some simplification. This is called pre-processing in computer program. We are doing some kind of pre-processing. Let's see if anything such pre-processing is possible before taking derivative for the second term. Derivation for term 2. First we do simplification. Mz by 2 q1 x1 ln theta 1 by phi 1 plus q2 x2 ln theta 2 by phi 2. This type of derivations I am giving you a task, home task. Does anybody know Mathematica software? The software called not MATLAB, Mathematica. Mathematica software, please look into that. The piloted versions are available. Okay? And this Mathematica software, if you give all the relationship, it can give the final formula. there is a command called simplify. Capital S, not small s. Simplify. And then third bracket you have to give the expressions. If you do that, Mathematica can do the simplification part. So all these derivations, whatever you are doing by hand, always cross-check with Mathematica. It's always better. Those days when the people did it, even I also did, when the time I didn't know how to do it. I had to do by hand. Because now I know Mathematica, so I can cross-check. Okay, so let's talk about the simplification part. The second term is this one, right? Of that equation A, equation number A, second term, we go to N1 of this. How to simplify? Nz by 2 Q1 x1. Then theta 1 expression is x1 q1 divided by x1 q1 plus x2 q. Phi 1 is x1 r1 divided by x1 r1 plus x2 r2. So what will be that? It will be q1 by q2 r1 into x1 r1 plus x2 r2 divided by x1 q1 plus x2 q2. Am I correct? Yes. Similarly, q2 x2 and then it will be q2 by r2 into x1 r1 plus x2 r2 by x1 q1 plus x2 q2. Further simplification is required. Nz by 2. How can I simplify? You can have q1 x1 ln q1 by r1 plus q2 x2 ln q2 by r2 plus q1 x1 plus q2 x2 ln x1 r1 plus x2 r2 divided by x1 q1 plus x2 q2. Yes? I am saying this equation number 2a with that same type I am doing. If you just take 30 seconds pause and look at term 1, how I was doing, I simplified the term 1 before getting the derivative part. Take the derivative. I have dou n1 or dou n1. First term will be kept as it is. Second term, when you take derivative, I will take this simplified term because it consists of the less unknowns. Earlier terms we have more unknowns, more complicated. So when you take derivative, so what we have learned from this mathematical calculation, when you have got a complicated expression, try to simplify, take derivative. If you don't simplify, your derivative is tedious. So that's the thing we have learned from this mathematical exercise. Okay. Next step. Next step is what? Derivative, right? We have simplified. So term 2 derivative. Dou n1 of nz by 2 q1 x1 ln theta 1 by phi 1 plus q2 x2 ln theta 2 by phi 2. So when we take derivative, this term will be as it is because dou n1 of dou n is 1. Z by q1 x1 ln theta 1 by phi 1 plus q2 x2 ln theta 2 by phi 2. Next, n is taken here. Z is a coordination number, constant, no problem. Dou n1 of this. Okay, so dou n1 of this, I won't write this expression like previous stuff. I write this expression. This is simpler. If I write this, I cannot take derivative. It's so complicated. So I write dou n1 of q1 x1 ln q1 by r1 plus q2 x2 ln q2 by r2 plus q1 x1 plus Q2 X2 ln X1 R1 plus X2 R2 by X1 Q1 plus X2 Q2. Z by 2, we can write Q1 X1 ln theta 1 by phi 1, Q2 X2 ln theta 2 by phi 2 plus Nz by 2. Now we can take derivatives. Here only unknown is X1. So it will be Q1 X2 by N ln Q1 by R1 plus Q2 into minus X2 by N ln Q2 by R2 plus, what will be the thing? You take derivative first, treat this as constant. Then treat this as constant, take the derivative. If I do that, it is Q1 minus Q2 X2 by N. Am I correct? Take the derivative. You have to make all the formula handy. It is not known now. Now you should not think about it. Devan, are you able to follow it? Ln X1 R1 plus X2 R2 divided by X1 Q1 plus X2 Q2 plus Q1 X1 plus Q2 X2 ln this will be, derivative will be what? What is that? It will be X1 Q1 plus X2 Q2 by X1 R1. Sorry, it will be X1 R1 plus X2 R2 by X1 Q1 plus X2 Q2. Is that over? Or something else you have to do? Is that over? Yes or no? dx of u by v. So you will take this again. v du dx minus u dv dx.
That will be because X1 Q1 you are taking 1 by that, right? So it should be like X1 Q1 plus X2 Q2 comes to be.
Okay. X1 Q1 plus X2 Q2 divided by X1 R1 plus X2 R2. You are right then? Yes, what is the term? What is the term? Into, I am writing here this term, that the space, some space I have kept. v du dx X1 Q1 plus X2 Q2 R1 into X2 by N minus R2 into X2 by N. I am doing it so easily. Minus X1 R1 in bracket X1 by X2 R2 ddx means X2 by N into Q1 minus X2 by N into Q2 divided by X1 Q1 plus X2 Q2 whole square. So simple. Okay. So it is X1 Q1 plus X2 Q2 into R1 minus R2 X2 by N minus X1 R1 plus X2 R2 into Q1 minus Q2 X2 by N divided by X1 Q1 plus X2 Q2 whole square, bracket closed. Now you can see why the people have not given this derivation. It is dangerous, right? I feel it is dangerous. It took me some sleepless nights. Okay. Next step. Okay, so first term is always straightforward. Z by 2 Q1 X1 ln theta 1 by phi 1 plus Q2 X2 ln theta 2 by phi 2 plus Z by, any confusion? Z by 2 simplified form. A and A will get cancelled. All n should get cancelled. If you do that, what will be your first term? Q1 X2 ln Q1 by R1. Am I correct? Q1 X2 ln Q1 by R1. Next term, quick. Minus Q2 X2 ln Q2 by R2. Next term plus Q1 minus Q2 X2, yes, ln X1 R1 plus X2 R2 by X1 Q1 plus X2 Q2 plus, I am taking this as one separate term, I am taking again Z by 2, X2 divided by X1 R1 plus X2 R2 common. What did you get? Did you understand this step? I am taking this term separately. This I am closing the bracket, I am saying I want to give this term separately. So it is, what is it coming? This and this gone. If you look at this and this, right? So term has become very simple. Term has become very simple. What is there? What are you getting then? What are you getting? Only these two terms will be there. These two and bottom X1 R1 is already have taken outside. So what's the term? The two terms will be there. You got lost, huh? I am not lost. You are lost. It's very simple. Yes. No idea. I am helpless actually. If you cannot understand 12th level calculus, what is the term? Yes, Q1 X. Can you please tell me? Q1 X1 Q1, X1 Q1, X2 Q2 into R1 minus R2 is there actually. Minus X1 R1 plus X2 R2 into Q1 minus Q2 is there. I am not doing anything extra. It is there. Next, Z by 2, Q1 X1 ln theta 1 by phi 1 plus Q2 X2 ln theta 2 by phi 2 plus next term, this set, you have Q1 X2 Q1 ln X2 Q1. What are the terms? Here it is there. So try to combine it. If you combine, what will you get? Q1 R1 into X1 R1 X plus X2 R2 by X1 Q1 by X2 Q2. What will you get? What will you get? You get a very simplified term. You have to combine this and this. Then secondly this and this. Only two terms will be there. From four terms.
Theta 1 by phi 1 and theta 2 by.
What will you get? Theta 1 by
Phi 1.
yes minus minus Q2 X2 ln theta 2 by phi 2. Levan, this there? Yes or no? Don't say yes sir forcefully because he is telling. You got it? Okay, third term. Simplify Z by 2 X2 X1 R1 plus X2 R2. Open up the bracket and see which terms get cancelled and give me the answer. Open up the bracket. Open up the bracket. I will tell you what are the terms you expect. X1 into bracket plus X2 into bracket. What is that? X1 into R1 Q2 R1 minus Q1 R2. Next X2 Q2 R1 minus Q1 R2. So what will be your term then? If you now look at Q1 X1 ln theta 1 phi. So if you combine them, X1 plus X2 will be 1. So you will be having simple Q1 ln theta 1 by phi 1. Similarly, you will see these terms got cancelled. Very interesting. So you get only two terms for term 2. What are these two terms? First time we got z by 2 q1 ln theta 1 by phi 1 plus z by 2 So if you look at this is actually, if you take common q1 r1 minus q1 r2, you have in bracket x1 plus x2. x1 plus x2 is equals to 1. So we have the top x2 into q2 r1 minus q1 r2 divided by x1 r1 plus x2 r2. I don't have to do even the steps. I can even visualize the steps because x1 plus x2 equals to 1. Okay, so z by 2 is nothing is x2 q2 r1 minus q1 r2 divided by x1 r1 plus x2 r2. Equation number A2, my both the terms are done. You have to combine it. Combinatorial part you have to now combine it. So combine equations A1 and A2. Combine equations A1 and A2. A1 you have, right? A1, A2 you have. So you have ln gamma 1c combinatorial part. What you got? A1 two terms you got. You dictate me. What you got? ln combinatorial part first term. ln phi 1 by x1 minus phi 2 into r1 by r2 minus 1. Yes. Then from here, second term, z by 2 q1 ln theta 1 by phi 1 plus z by 2 x2 q2 r1 minus q1 r2 by x1 r1 plus x2 r2. Phi 2 into r2 by r1 minus 1 can be written as, you have to combine these two. You have to combine this guy and this guy. So phi 2 into r2 by r1. So if you define the other steps, what you get in terms of x1 r1 x2 r2? What is phi 2? x2 r2 divided by x1 r1 plus x2 r2. Okay, so what you get? Can you get x2 into r1 minus r2 by x1 r1 plus x2 r2? Are you getting? Yes. The one lost, huh? Yeah. If you are lost, that's it. I can't help it. Okay. Next step. x2 into r1 minus r2 x1 r1 plus x2 r2. We can write this as x1 r1 minus x2 r2 minus x1 r1 minus x2 . See, so much of jagda you have to do. x2 x1 x2 r1 minus x2 r2. What I am doing? I am adding x1 r1, subtracting x1 r1. Okay, what you get? You will get very simplified formula from here. What you get? You see, can factorize. What you get? x1 r1 plus x2 r2, you can take it outside, you will give minus 1. x1 r1 and x2 r2 you take outside, and that fraction will give minus 1. What will you get here? Pardon? Please simplify, don't be so lazy. I am helping you. This term and this term, if you take outside, this will get cancelled, you get minus 1. Did you get it? No. What is the simplified term? So all the term remaining x2 r1 minus x1 r1, right? Or plus x1 r1. What is that? r1 by x1 r1 plus x2 r2. What is that term? That's what I'm saying. So this term got to a very simple simplified term, right? Phi 1 by x1. Next, this term is there. How to simplify this term? I'm saying this is equation number B1. Within 5 minutes will be done. This term is simplified, this term is simplified, this term is there simplified, you cannot do much this term. Z by 2 x2 into q2 r1 minus q1 r2 divided by x1 r1 plus x2 r2. What should I write? Z2 x2 q2 r1 minus x2 q1 r2 divided by x1 r1 plus x2 r2. Next, z by 2, we can write this as q2 x2 x1 phi 1 minus q1 phi 2. Can I write? Yes. This one I want to write z by 2 phi 1 x1 q2 x2 minus q1 x1 phi 2 by phi 1. Can I write? If you don't agree, please tell me. Z by 2 phi 1 x1 into q1 x2 minus q1 x1 phi 2 by phi 1. Can I write? Yes or no? Because phi 2 is nothing but 1 minus phi 1. Because phi 2 is nothing but 1 minus phi 1. Okay? So can I write this as z by 2 phi 1 by x1 q1 x1 plus q2 x2 minus q1, equation number V2. Yes? Yes or no? If it is no, I can explain. Yes? Yes or no? No. Yes or no? Yes? Rahul said yes. Anybody said? Anybody else? Yes or no? Don't do back calculation. That's what it does. Back calculation. Don't do back calculation. It should come automatically. It's coming automatically, Rahul? Devan? Yeah. It is property. It is not my assumption. It is coming from definition, right? Phi 2 plus phi 1 equals to 1. That's it. Binary for binary system. Okay. From equation number B. So what you can do from here? Yes, start from here. We have done all simplification. Ln phi 1 by x1 plus z by 2 q1 ln theta 1 by phi 1. This one I have got phi 1 by x1 minus 1, right? Something like that. X1 minus 1, right? So you get minus phi 1 by x1 plus 1, and then last time we got z by 2 phi 1 by x1 into q1 x1 plus q2 x2 minus z by 2 q1. Am I correct? From here, you go home and try to prove that this is only few more steps. Phi 1 by x1, z by 2, q1, ln theta 1 by phi 1. plus L1 minus I1 by X1 summation j equals to 1 to 2 Lj Xj, where Li equals to 1 minus Z by 2 Qi. So this is your combinatorial part. This is the statement not there in the book. This you can treat as expression of TB, my name. This is TB expression. Now I will show Sandler gave the expression without proof. Here is the fun. If you can spend with me 2 more minutes. This you can prove. Go home and prove it. I want to see that because only 3 steps. This you can prove. Abhijit, please don't do back calculation. You won't have the fun. Don't do back. This is coming automatically. It will come. Don't worry. Sandler gave the expression. Sandler, all my friends, YBCR, all these people, entire gang of thermodynamics community, gave the expression ln gamma 1c, ln phi 1 by xi, so far okay, right? Plus z by 2 q1, ln theta 1 by phi 1, so far okay, right? Plus L1, so far okay, minus phi 1 by x1, summation j equals to 1 to 2 Lj Xj. Same. Don't be happy. Li was defined differently. Li is z by 2 Ri minus Qi minus Ri minus 1. My Li is 1 minus z by 2 Qi, and there. So what did you say? Who is correct? Of course, don't say that, in the class, if you say you are wrong, that means I will give you all U grade. Who is correct? Any idea? Who is correct? Tell me. Let's see who can give me the correct answer. I am just asking simple question. Any guess? Who is correct? Both are correct. Yes, that's the right answer. How to prove? Both are correct. How to prove this Li and this Li is same? So Li of TB and Li of Sandler. So Li of TB should be equals to Li of Sandler. Otherwise, expressions are not correct, right? That is, next class will be coming for the proof. So this will go home, do the derivation, and now we can see that the corrected textbook should have this expression, not that expression. Okay, that's all for your class.